What's going on, everyone? MTech here. I figured I'd get this efficiency breakthrough update out there. Um, the system will now run itself for a short time after the transmitter is switched off, meaning when I switch the transmitter off, it'll still run itself for about a minute after the system is de-energized. And that comes from the all the reactive components in the circuitry, all the storage in the capacitors, the inductors, and the DC boost board has built-in capacitors too that contribute to that. Anyway, there was a major breakthrough made with the system regarding a biasing resistor. It is a 1 mega ohm 5 watt carbon film biasing resistor connected to the base of the transistor, and that seems to be key for stabilizing the system. Negative resistance is now dominant in the system. The negative resistance seems to be an emergent property of the system as a whole, meaning the negative resistant property emerged as a combination from all the parts put together acting greater than the sum of the parts. Kind of like an emergent phenomena, how if you twist, how a single strand of string is weak, but if you put a bunch of strands of string together and twist them, it can form a rope that can hold army tanks as it passes over a bridge. But anyway, we now have a more refined resistor network. It's now 300 ohms with a parallel 10 nanofarad capacitor. Nothing gets hot anymore when the transmitter's in this mode of operation. So I'll switch it on and show you. These are just ferrite tuning rods. This coil will light wirelessly. I also installed this milliamp meter here because I couldn't believe that the system was consuming such a small amount of power. So what happens is this 12 volt 6 amp hour Lifey PO4 battery powers up the transmitter. The Lifey PO4 battery powers up this DC boost converter, boosts the 12 volts to 96 volts DC. That 96 volts DC passes through an analog current meter, and I couldn't believe what it was reading, so I installed an additional sensitive digital current meter to confirm it, and it is true. So the current flowing through the transmitter passes through these series connected meters, these two series connected meters, goes through our resistor shunt, which according to Don Smith accumulates excess resonant energy. That correct capacitor is key to having the system work. Without that correct capacitor, the system won't even turn on. Seems to be a delicate balancing game. So I got that figured out. Again, this is a 300 ohm resistor chain. It's just three 100 ohm resistors in series. They are cement resistors, 20 watts apiece. It is overkill, you don't need it. If I switch the mode of the transmitter from the hyper energy efficient mode into the standard mode of operation, it will dissipate heat and you will need these resistors. Everything in this mode of operation remains cool. So I'll turn the meter on. I will turn the transmitter on. So the transmitter is now on, and it's only consuming 1.5 milliamps. The transmitter is consuming 1.5 milliamps to create wireless power, which is insane. And it's detectable through this little light here. A 4.7 nanofarad high quality ceramic capacitor was needed to be installed in parallel on the biasing resistor, because I think the capacitor is changing the phase angle of the energy, creating more of the negative resistance. And so we have a 96 volt DC input at 1.5 milliamps, and the heavier the wireless load you put in the area around the transmitter, the less power the system will consume, which is insane. And I put this is just a receiver coil, a quarter-sized Tesla pickup receiver coil, wound per Tesla patent 336961, and I can get this light to glow very bright if I tune it properly. I can get this nice and bright by tuning. There we go. That's very bright. So as you see, it's almost like we're manifesting power now through the receiver coil. There is no higher power consumption in the transmitter if I get everything adjusted just right. No higher power consumption. These little lights are lighting just in the field around it. It's crazy. I can also light an LED here. If you run nonlinear loads with the system, like LEDs, which are nonlinear loads, it seems to really help the negative resistance. So as you see, this light is lit. This LED light is lit off of our receiver coil. And I have to retune again this little coil, but if I grounded it, it would glow bright. So if I add an earth ground connection here, it would also glow bright. The system is consuming a little more power from running this LED, but this was the efficiency breakthrough discovery. Now, if I switch the system off, and I'll show this with an Avraменko detector plug in my hand. Now, when I switch the system off, it's going to continue to run itself for a bit. The system is off now. It is fully switched off and still running itself. And it will do that for about 2 minutes. And the further I want to extend this effect would be determined by the amount of capacitor storage I implement into the positive DC input of the transmitter circuit. So right now the system is slowly decaying because the negative resistance doesn't quite overcome the positive resistance in the circuitry. Once I can get enough negative resistance injection into the circuit, it should fully self-sustain itself by canceling out the positive resistance. So I have some diacs on the way to hopefully help with that problem, and I'm going to try and obtain some tunnel diodes and experiment with putting them in a configuration around the biasing resistor. So the system is fully switched off now, and minute wireless power effects are still present around the system. They are dying down and fading down slowly, but the system is hyper efficient, and I've even seen it last as long as 5 minutes when switched off. So it's almost like the system can manifest power when the correct conditions are met, and enough negative resistance cancels out the positive resistance of the circuit. So as you see, we're consuming 0.1 milliamps, but yet we still have a very faint wireless power field present near all conductors and near all components of the system. There's a field of energy, or a field of perturbation, around the system that you can still extract small amounts of wireless power from. And it is slowly fading out. It will eventually completely go dead, probably within about 4 to 5 minutes. That light is slowly getting dimmer. So now I will switch the system on again and show you the negative resistance effect on the oscilloscope. So I'll get my oscilloscope brought over. And I noticed too that the negative resistance effect, when the transmitter is in this mode of operation, you will detect the negative resistance effect in all receiver components and within the transmitter. The waveform will look like a waveform that starts small and then grows bigger over time. So I'll try and do this. Sometimes the oscilloscope also has trouble reading the negative resistance, but try and get it going. I'm going to try and get this going. It's really noticeable on the Tesla receiver coil. So I'm going to auto-tune the oscilloscope. And as you see, the waveform starts small, then gets big. I do have pictures of this in the scope view. And it's really visible if I disconnect the LED and do a reading on the transmitter itself, you see that the waveform starts very small, then gets big. So that is the negative resistant waveform, and I'm doing a reading on the transmitter at the biasing resistor. So that seems to be where the negative resistance is focused, and the negative resistance was caused as an emergent property from the correct 4.7 nanofarad capacitor shifting the phase of the energy within the transmitter. So the capacitor is phase shifting the energy within the transmitter by being parallel installed with the 1 million ohm, the 1 mega ohm biasing resistor. I'm not sure if that is the ideal resistor value. It might need to be 2 million, and the transmitter might even draw half that power to do the same wireless power effects. So the highest resistor value I have is 1 mega ohm. I might experiment with putting two 1 mega ohm resistors in series to get a 2 million ohm resistor, or maybe even put a potentiometer here, and the transmitter might even draw half that power for the same effects. And again, the system is so close to self-sustainment, because we can clearly see the negative resistant waveform on the oscilloscope. The dominant frequency is 220 kilohertz, and when I switch the system off, wireless power remains present in the system for 2 to 5 minutes, and that is a very strong indication of near self-sustainment. Again, I need the correct amount of negative resistance injected into the circuit to completely counteract the positive resistance to achieve full self-sustainment. It's that simple to do it. We have to cancel out all positive resistance and we're in business. So, there's the effect again on the oscilloscope. We're doing a reading on the capacitor junction point on the biasing resistor. So all that biasing resistor does is it triggers the transmitter into a much more easier oscillation state. You don't have to touch the transistor anymore to trigger oscillation. It makes it more efficient. The transmitter always starts now with that biasing resistor installed. And again, there's how the negative resistant waveform looks. It starts almost from nothing and grows. Negative resistance actually injects energy into the circuit. It's theorized that negative resistance actually synthesizes energy into the circuit, and the energy synthesis either comes from a different dimension or out of the environment itself, possibly from the earth ground we have on our circuit. In probing all parts of the transmitter circuit, now I'm probing the ground connection, will still show the negative resistance wave. So the wave starts very small, then gets very big, and then dissipates again. So something is limiting the negative resistance effect from getting completely carried away and blowing the system up. Part of tuning this system is by sliding the coil, the quarter-sized coil, over the transmitter. So I figured I'd show those effects. I'll get them out there. This glows very bright up here. So I will now shut the system off again, and we will watch it slowly wind down in power. Get this light nice and bright, show you the effect. The system is now switched off. We are still running. It's switched off, mind you. The negative resistance waveform is still visible on the scope. The system is fully switched off. The negative resistance waveform sustains the transmitter's operation for a time, but it can't quite cancel out all the positive resistance yet. We're still in a small deficit, and therefore the system slowly dies down and will eventually fade out. And we're seeing that effect. We're so close to self-sustainment, true self-sustainment, in this mode of operation. If anyone knows anything more on how to fully achieve self-sustainment, let me know. We're so damn close. And thank you, everyone, to all our supporters. Feel free to check out our Patreon. We sell a $5 book fully guiding how to build this system, and it's only $5. The book ties in a lot of concepts from old electrical engineers. So as you see, the wireless power effects are fully fading down now. For some reason, these little detectors are super sensitive. So the system's just about going out. Power consumption is 0.2 milliamps, yet there's still very faint amounts of wireless power in the system. I've never seen anything this efficient before. Now we're even at 0.1 milliamps. That's 1/10 of 1 milliamp producing wireless power effects. How is that even possible? 1/10 of 1 milliamp, and you can visually see the wireless power effect. So, this device is showing signs of multiplicative field effect phenomena, I should say. It is at the borderline of self-sustainability. What keeps it going once I shut it off is multiple things. When I shut the system off, the all the energy storage components in the system keep it going for a time, and the meter can't even read any power being consumed anymore, yet there's still wireless power present. So we're consuming less than 1/10 of 1 milliamp now, and we still have visible wireless power present. Like I said, I couldn't believe this effect. I plugged in my sensitive digital meter here to confirm the results of the analog meter, and both meters are correct. So the effect is also really visible around loops of wire. Like this is just a loop of wire, and yeah, now the system fully went dead, so there's no more wireless power present at all. The system is fully dead. I think I might get into the idea of toggling, having a very efficient toggle or a timer that automatically turns the 96 volt DC on and off. Like maybe it'll pulse it for 0.1 seconds to go in there. You know, it'll pulse the power. That might be more efficient, but I would like a fully self-sustaining system. That would be the holy grail, and we're nearly achieving that through negative resistance. So again, I'll turn the system on. I'm going to turn the system on just for a second and switch it off. So as you see, I switched it on for just a second, and now it's off. This is how crazy the system has become. And again, the negative resistant waveform is visible on the oscilloscope. Looks very interesting. Starts from virtually nothing, grows big, and then slowly decays because something is limiting its exponential growth to infinity. If the waveform did grow to infinity, some of the components within the transmitter would blow up. So we are slowly fading out now on power. And apparently the system can run at less than 1/10 of a milliamp and still output wireless power. That is insanely efficient. So to achieve full self-sustainment, we need to inject enough negative resistance into this thing, and we're in business. So I think we're almost there. I thank everyone. Feel free to like, comment, subscribe, join the Patreon. And something else interesting of note I will show is I'm gonna put the transmitter in normal high power mode of operation now. So I'm gonna turn the transmitter on. I will slide adjust this coil into proper position for high power mode to occur, which I believe is right near the resistor. And I have to disconnect the capacitor here, which creates a phase adjustment. So now the transmitter is in normal operation mode, but it's still in a very efficient form of normal operation. Like this light is lit very brightly because we're running a non-linear load. And why are all these leads twisting so bad? I swear, you make a video, everything will twist and fight you. So we are only consuming 0.2 milliamps to wirelessly run a non-linear LED load from our Tesla receiver coil. I've actually never seen it that efficient. So that's just a wireless coil that sits over it. And all I did was disconnect our capacitor here. This is just a phase adjustment capacitor. Connecting it reduces our brightness. Connecting that capacitor emphasizes the negative resistance effect. I don't even know what the hell happened. I've never had it that efficient before. We're consuming 0.1 milliamps, and yet we still have output. I've actually never seen it this efficient. This might be something new caught on camera. That's crazy. Hold the scope to it. Again, that's how the waveform looks on the scope. Starts small, gets big. It almost starts from nothing, then gets big, and then decays. So, our analog current meter is reading nothing. Well, it's not that it's reading nothing, it's that it's not sensitive enough to detect the small amounts of power the system is using. That's why I installed the digital meter as well, and I'll switch the system off now. It's off. And we still have sustained output for a time from that negative resistance. And it will eventually fade out. And I can adjust this coil too. There we go. As you see, the system is slowly fading out and it's flickering a little. It wants to sustain itself so badly. The system is completely off now, mind you. System is completely switched off and de-energized. Not even consuming detectable levels of power, yet we still have an output. This is the most insane levels of efficiency I have ever seen, and we are so close. And now the slight positive resistance has just about taken over. I'm not even detecting power consumption anymore, yet we still have wireless output. The system's getting into a state where it's almost about to manifest power, just due to its special Archform of construction. So this is getting very, very interesting, very efficient. Negative resistance still faintly detectable on the oscilloscope. And now I was going to show the transmitter entering its higher power consumption mode, so I'll switch that on. I will connect an incandescent bulb to the system. I do have one here, the little one. I should have had this set aside. Move this closer, see what we got. It's just a little incandescent bulb buried in here somewhere. Ah, there it is. So, I will now connect a standard incandescent bulb. And to get it to run normally, I have to disconnect that capacitor here. And now it will enter a new form of mode and run. And this form of transmitter operation is very good at recharging batteries. So now I'll connect up the oh, I'll show you the waveform on that too. So the waveform now is very interesting looking. I can do auto set, doing everything one-handed. So now the waveform is a standard square wave. Negative resistance is not dominant when running an incandescent bulb from the transmitter in this mode. And the high frequency is messing with the digital meter, not giving an accurate reading, because it's in a higher power mode. So I will now disconnect the incandescent bulb, hook up the LED. It enters a more non-linear mode of activation. The digital meter becomes accurate again, and it's important to note that the analog meter was accurate when I was running the incandescent light bulb. So I'll show that. I hook up the incandescent light bulb. It is a 10 watt 12 volt light bulb being wirelessly run from the receiver coil. I disconnect the phase adjusting capacitor. It will glow. The analog meter gets a little glitchy. The digital meter gets a little glitchy on reading the power consumption because it's subject to the high frequency. But nonetheless, the analog meter is accurate now. It's showing power consumption to run the incandescent load. Our wireless receiver here, this little LED wireless receiver, I've blown a few of them by doing this. Just by adjusting the rod, we'll get the light to go very bright. Highly bright. I'm scared to get it any closer. Playing around with this will not draw power from the transmitter either if you're far enough away. So again, to get it into that negative resistance dominant region, we hook up that capacitor. We run a non-linear load such as a LED, not so much an incandescent, because incandescents are resistive loads. So now we're in a highly nonlinear state. The analog meter is reading nearly no power consumption. This is the negative resistant near magic-like state in the transmitter. The digital multimeter is now accurate because it's not subject to that overbearing high frequency square waveform as when the transmitter is in the other mode of operation. The negative resistance has taken over, as you can see on the oscilloscope. So the wave starts small and gets big. To auto set that. That was very interesting. Yeah, as you can see that the waveform starts small and gets very big. So that will conclude the video. Thank you everybody. I had to show that breakthrough update. I will shut the system off now. It is off. And it will still run itself for a time, very efficiently. We are so close to self-sustainment. So close. And the system slowly winds itself down. So, people want to peek under the desk. So, peek at my work desk. System is slowly winding itself down to the point where it doesn't output wireless power anymore. The storage elements store all that wireless power in the form of fields within the conductors, the capacitors, the reactors, the inductors. And the negative resistance can't quite take over the positive resistance yet. We just don't have enough negative resistance yet in the circuit to achieve full self-sustainability. But yet we are so close. So close. It's almost like the system can manifest power just due to its Archform. And as you see, this will slowly fade out as I'm holding it. Slowly dimming out. Very interesting. And it is out. Yeah, so thank you everybody. Feel free to like, comment, subscribe. This is ongoing research to try and create, with real science, a fully self-sustaining energy synthesis Joule thief transmitter system that uses Eric Dollard's theories, Ken Wheeler's theories. Feel free to check out their channels. They're great experts in their fields. We're so close to self-sustainment. Feel free to like, comment, subscribe, join the Patreon, and even buy the book if you'd like to support us. It's a simple $5 book. Tells you in great detail how to build all these systems, and it's only $5. It's even less expensive than the cost of a sandwich at my work. So yeah, feel free to like, comment, subscribe, join the Patreon, support the research. We also sell versions and kits of this system pre-made if you want to buy one instead of order one. There's about a 1 to 3 month wait on any systems that are bought. We build and tune them to near perfection as best as we can and ship them out. Shipping anywhere in the USA only costs about $30. If we ship it worldwide, shipping can get expensive. And that is an option if you don't want to buy the $5 book, read the book, which it also serves as a guide to build these systems. You can also buy one from us on our Patreon. All links will be in the video description. And yeah, thank you everybody. The knowledge is out there. Only $5 for the book. I had a few people complain, why are you charging for the book? It's like, well, a lot of work went into the book, from Ken Wheeler's ideas, my ideas, Eric Dollard, all the the book takes all the ideas of ancient electrical engineering masters, puts them in a concise location for someone to utilize properly as a framework. So the book took a lot of effort to make, so I charged $5 for it, and that's not even a lot of money. So I could charge 20, but I'm charging 5. So that's why I'd like to get a little bit of money for my work, to support myself in life and all these experiments. So thank you everybody again, and feel free to like, comment, subscribe, join the Patreon, or buy the book, and take care.